Okay, in this lesson, we're going to look at how to represent motion with graphs. So we'll start with the scenario here where a boat is moving to the right at 10 meters per second. Okay, so let's plot the position, the x position, at every single second. So we'll start over here. So at time 0, the boat is at position 0. After 1 second, it's around position 10. After 2 seconds, it's at position 20. After 3 seconds, it's at position 30. Okay, so even though we have 4 data points, we could draw a line of best fit. It's a straight line like that. Should be a straight line. Use a ruler. And then we can also plot its velocity as a function of time. So because the velocity is not changing, at each second, okay, it's going to have a velocity of 10. And we put a straight line to say like we can interpolate in between those lines. Okay, that's brutal. Let's do that again. Okay, so one thing you can notice is that this here is uniform motion, and so our position time graph for uniform motion, okay, is a straight line. So that's uniform motion. On a velocity time graph for uniform motion, the line is a straight horizontal line because the velocity is not changing through time. So let's see how that would change if the velocity was changing or if the object was accelerating. So let's try this scenario here. Let's look at the velocity. Let's go back to the position time graph here. So at time 0, we're at position 0. Maybe we can do a different color here. We can do blue. At time is equal to 1, we're about 5. At time is equal to 2, we're about 20. At time is equal to 3, we're about 46. So 346. Okay, so in this case, you could see that it's not a straight or linear relationship. In this case, we have a square relationship that increases as a square. And so if we were to plot our velocity versus time graph, well, at time 0, we had 0 meters per second, time 1, 10, at time 2, 20, and at time 3, 30, we get a straight linear line. Okay, so a curved position time graph, okay, means that we have acceleration. Whereas a linear increasing or decreasing graph on a velocity time graph means that we have acceleration. Okay, so the big thing in this lesson is to understand or to describe motion from motion diagrams. So let's see how to interpret this graph over here. We'll start with the position time graph above. Okay, so a couple of things that we can know. Okay, here we're starting at, let's go back to red. We're starting at position 30. Okay, and then we're going through time and we're going closer and closer to the origin. Okay, so we are moving left. You know, we're at position 30, position around 20, 10, and then at 0. Okay, so this, when we cross the origin here, just like over here, we are moving past the origin. So we move past the origin at that point. Okay, so what's happening in this time interval here? Well, we're moving left because we crossed the origin. Now our position is -10, -20, and -30. So over here, we are moving left. Over here, our position is not changing through time. So here, we are standing still. And then here, we are moving towards the origin. So we're moving right, and then we move past the origin and keep on moving right. So here, we are moving right. And then here, again, we are standing still. Okay, so let's look at the same shape, but this time, instead of being a position time graph, we're going to have a velocity time graph. Okay, so at time 0, we are moving at 30 meters per second, and then we're moving around 20, then around 10, then here we come to a stop. So here, we are slowing down. Our acceleration is negative here. Okay, we're slowing down. And we're still moving to the right because our velocity is still positive at each of these points, so we are moving right, even though at a slower and slower rate. Okay, at this point our velocity is 0, and right after that our velocity is negative. So we change from having a positive velocity to a negative velocity. So the origin in a velocity time graph is called the turnaround point. Okay, it's where we're going positive direction and then we're going to negative direction. Okay, so here our velocity is negative, so we have negative velocity, and we are speeding up because the negative velocity is increasing in time, so we're speeding up. Very important. Okay, here our velocity is not changing through time, so we are we have constant velocity, or the acceleration is 0 in this case. Here we are moving left because our velocity is still negative here, but we're slowing down and slowing down. Here we come to a stop. It's another turnaround point. Okay, and here we're moving right and we're speeding up, and here we're moving right with constant velocity. So this is constant velocity.